This next piece of our law of signs looks at what if we have a possibility of having more than one solution. For example, what if it's possible to have two solutions? Or what if it's possible to have no solution? We look at those examples in this video. So in order to do that, we need to have a geometry flashback. Yes, that's right. Think back to geometry. And remember, what were the 5 ways that you could prove triangles congruent? Well, if you remember the 5 ways that you can prove triangles congruent, what that's telling you is that that's a unique solution. So for example, side, side, side. If you had all 3 sides given, it was only one unique triangle. Side, angle, side. Again, a unique triangle. Angle, side, angle. A unique triangle. And again, 2 other ways. Hypotenuse, leg, obviously one of them. Not really helpful here. But angle, angle, side was the other one. So if we have those ways to prove triangles congruent, that means we're only going to have one solution. So actually drawing a picture is really helpful for these types of problems because when you draw the picture, you know whether there is a possibility of just having one solution or the possibility there could be 2 or even none. When we look at problems like angle, angle, side, and angle, side, angle, these are all triangles that are dealing with 2 angles and a side. Now, whether we know the side between the 2 angles or the one that's adjacent to it, that tells us whether the triangles are going to be congruent. So this basically tells us that if we know 2 angles and a side, then the triangle has to be unique. And if you think about it, it makes sense. If I know 2 angles, there's only got to be one other possibility for the 3rd angle. So regardless of which side I know, it's got to be a unique triangle. But what if we only know 2 sides in one angle? How do we know if the triangle is unique? Well, there's 3 possible solutions. 1, no triangle exists. 2, we have a unique triangle that exists. Or 3, 2 triangles exist. Now, it's that last one that people get stuck on because they're like, 2 triangles exist? How is it possible we could have 2 triangles? Well, let me draw an example. In this example, I've got sides A and C are both exactly the same side. So side A is congruent in both of the triangles as well as side C. And angle A is also the same in both triangles. So we've got 2 sides and an angle that are congruent, but clearly these 2 triangles are not congruent. This means that I could possibly draw a second triangle with this information. Remember your geometry teacher telling you you can't prove triangles by side, side A. So for a triangle to be unique, we need to start with 2 sides and an angle that would be where? Well, we know the angle would have to be included, and that would make it side, angle, side. So the only time we have information of a triangle where we know 2 sides and an angle and it's a unique triangle is when it's side, angle, side. So what do we do in a problem where it's not the 2 sides and the angle that's included? Well, we're going to assume that there are 2 solutions and solve the problem. And if we find out there's not 2 solutions, we'll eliminate the ones that are not possible. This will make a lot more sense once we look at an example. So let's look at an example and talk about how we know if there's 2 solutions or not. So here's our situation. We've got an angle and 2 sides that are given. And again, it's not side, angle, side, so we don't want to assume that we have just one solution. So let's set up our law of signs. So plugging in what we know to our law of signs, we'd probably decide that the first thing we'd want to find is angle B. So we cross and multiply, we solve for angle B. If you guys do that on your calculator, you should find that angle B is going to be 21.4. Feel free to pause this video anytime in between to verify to make sure that you're getting the same solutions. That would actually be really helpful as you're going through to do the problems tomorrow. So let's do this. Let's assume that there are 2 solutions and check how feasible it is. So first, let's take the answer we got and find out what could the second answer be. Well, how do we find out what the second answer could be? Remember in the last video, I talked about the fact that the sine of a supplement is the same as the sine of the angle. So what we need to do is find the supplement. If this is the angle that we found, we need to find out what the supplement of that angle would be, because the sine of both of these angles would be the same. Remember that supplementary angles add to 180, so if I take 180 and I subtract my angle, this would give me the other possible angle. You'll notice in the book that they use this notation, which we read as B prime. This just means it's the second possible solution. So we've got angle B, which is 21.4, and we've got B prime, which is 158.6. All right, so we've got what the possible second solution would be. Now we need to check and see if it's possible. So if we've got 2 possible answers, how do we check and see if they're possible? Well, remember that thing about the whole sum of all the angles in the triangle have to be equal to 180? Well, we know that if we add the 3 angles and they up to more 180, then it's going to have to be not a possible solution. So keep in mind that it is possible that both solutions could work. But If we have one that doesn't work, then it's only one solution. So the two angles that we knew were 42 from our original problem, and the one we just found, the possible 158.6. Well, if I add this other second possible angle and the angle I already knew from the problem, they already are greater than 180. So there's no way there could be a third angle that would make this triangle work. This tells us that there's only one solution in this problem. So if there's only one solution, we just continue the problem like we did in the last problems. So remember though that if you have two solutions, then you need to find both answers. And we'll do an example in a second, but let's finish this problem first. And yes, this means that if you have two solutions, you're going to have two sets of angles and two sides for each triangle. So we already found that angle B was 21.4. So now we need to find our angle C and side C. So if we eliminate this and we set it equal and we solve for C, we can find that angle C is going to be 116.6, and then plugging that in and finding side C, we can find that it's 29.41. Take a minute to pause the video and make sure that you do get those two solutions. Alright, so we saw an example that worked out that it only ended up with one solution, but we do need to see one that gives you two to make sure we know how to do this. So here's a problem that we know is going to have two solutions, and we're going to work through this together. First thing we want to do, obviously, is plug in what we know from our law of sines. If this was the information I had, which angle would you probably solve for first? Probably angle C. So let's cross multiply and solve and figure out what we get for angle C. Alright, so we cross multiply and we solve to find angle C, and we find that angle C is going to be 82.9 degrees. So again, we know there's a possibility to have two solutions. So how do we find the second possible solution, which we'll call C prime? Well, remember, we know it's going to be the supplement of the angle we just found. So if I take 180 and I subtract 82.9, I find that the other possible angle is going to be 97.1 degrees. Now, again, we right now assume there to be two solutions, but there's a possibility there could be one. So how could we check? Well, let's take the angle we just found and say, is it possible to even find a third angle? Well, look at the angle that we had earlier, 78. Take the angle we just found, 97.1. When you add these two angles up, is this value greater than 180 or less than 180? Well, we find that the answer is less than 180, which means there's a possible second triangle. So yes, we're going to have two solutions. We are going to solve these independently though, because angle C over here was 82.9. This is going to have a different angle A than this triangle over here, so we need to find those. The nice thing is they're pretty easy because we know all three angles have to add to 180. If I take the angle I already know, remember this angle stays constant to both triangles, just the same thing as side B and side C do. So if I take my angle B and an angle C that I found and I subtract from 180, I find that my angle A is going to be 19.1 degrees. So let's go ahead and set this up. Obviously, we're going to say we know angle, when you can work from angle A or C that you want to work with. So we're going to say sine of angle A over side A is going to equal to, and again, you can choose any one. Since I was given in my original triangle, both of those, I'm just going to go ahead and use that. And then solve my triangle to find side A. And when I do that, I get about 69.25. So this is the first triangle. Remember, we have a second triangle. So if angle C is 97.1 and angle B originally was 78, subtracting from 180, that means that angle A, while a small angle, still a possible angle, 4.9 degrees. Again, I'm going to set up my problem. So sine of angle A over side A. Again, I can set it equal to the same one because we know the information was the same for both of these. And when I cross multiply and solve, I find that side A, which we'll call A prime, is going to be 18.08. So in a problem like this, when there's a possible two triangles, yes, you need to find both solutions. And again, we use this little symbol prime to show that there's a second solution. We're not going to worry about any more than two solutions, so don't worry. It's either going to be 0, 1, or 2. So that's going to be a problem where we have two solutions. So what would it look like if you have no solution? I'll show you that one real quick too. So we know, here's an example. I'm going to show you why this is going to give you no solution. So when I plug in my law of sines here, so when we go to solve this one, we're going to go ahead and cross multiply. And obviously we're going to probably try and solve for angle C, because that's going to be the easiest one to get to. So when I cross multiply to solve, I'm going to find that sine of C equals 2.057. But remember, sine can only be restricted. It has to be between 1 and -1. So if you try putting this on your calculator, it's going to give you an error. It's going to say like not possible, no domain error, or something along that lines. And the reason is because there's no solution. So you can't take inverse sine of 2.047 or 57 because it's not a possible solution. The nice thing about a problem with no solutions is as soon as you get to this point, you're done. This is the answer. No solution, no further work. No solution problems are nice. So what you want to make sure you do is be very careful. Whenever you have a problem where it's not a unique triangle, remember one of the ways that you could prove triangles congruent, you always want to assume that there are two solutions. So when you can assume that there's two solutions, you're guaranteed that if there is a second solution, you're not going to forget to find it. Remember to check and see if there is a second solution, take the second solution you found, add it to the angle you already had in the original problem, and compare it to 180. If the two angles you have are greater than 180, there's not a second triangle. If the two angles added together is less than 180 though, you do have a second triangle, and yes, you need to find the other missing sides as well as that angle. So here's a couple practice problems for you to try. This is your goal between now and when I see you next class. Please have these problems done so we can go over the answers. The first one is to solve the triangle, and the second one is just to answer the question, how many triangles do we have? Is it a problem where you have 0, 1, or 2 triangles?